going on, guys? Let's do this problem right here. This question is asking find the magnetic field 30 cm to the right of the second wire. This is the location, right? And let's see what is the direction of magnetic field is going to be due to each current's direction. Here we are going to use right hand rule, and if you look at this one, this current in the first wire is going in the upper direction, and if you use your right hand rule and if you point your thumb in the current's direction, you will see your hand will curling around. It's like it's going inside, right? If you curl, it will go inside. So the magnetic field due to this one is going to be inside. So here we are trying to find at this location. So let's put inside for the first one. So this is B1, right? Due to the first current. And let's see what happens due to the second wire. Right here, this current is going down direction, and if you point your thumb toward this current direction and curl it, you will see that your curled fingers will point outside. So this means this magnetic field is coming outside due to this current. So let's call this one B2, right? So we have now B1 and B2, and let's see how we can find the magnetic field. To find the magnetic field, we can use this equation, that is B. First, let's try to find for this one. B1 magnitude is equal to mu naught I, right? Mu naught I1 over 2 phi R1, right? This is the one we are going to use. Mu naught is going to be 4 phi times 10 to the power of minus 7 Tesla meter per ampere, and the first current is given by 5 ampere, so this is going to be multiplied by 5 ampere, and in the denominator we have 2 phi, and the R1 is going to be the distance from first current to here. This is 20 centimeter, and again we have 30 centimeter right here, so total distance is going to be 50 centimeter. But if you want to convert this one into meter, you have to divide by 100, and that's going to give you 0.5. right? So this is what we get for the first magnetic field due to the first current. And if you calculate this one, this is going to give you 2 times 10 to the power minus 6 Tesla. And let's see what we get for the second current's magnetic field due to second current that is coming outside. And let's say this is B2 magnitude and mu naught I2 over 2 phi R2, right? Mu naught is going to be same 4 phi times 10 to the power of minus 7 Tesla meter per ampere times the current. Second current is 10 ampere, so this is going to be multiplied by 10 ampere divided by 2 phi, and the distance from the second wire is 30 centimeter, so this is going to be 0.3 in the denominator. And if you calculate this one, that's going to give you 6.67 times 10 to the power minus 6 Tesla. So these are the two things we have. And if we say this is y direction, this is x direction, let's call this one z direction, right? So if it's coming out, let's call this one, if it's going in, negative z, if it's coming out, positive z, right? So first one, this B2 is coming out, so we are going to use positive for this one, 6.67, and then B1 is going inside, so we are going to use negative for this one. So we are trying to find the total magnetic field. Let's calculate it. B total is equal to B1 plus B2, right? So first one, this one, B1 is going inside the board, so it means negative z direction. So let's put negative 2 times 10 to the power of minus 6 Tesla in the z direction. And the second B2 is coming outside, so this is in the positive z direction, so this is going to be plus 6.67 times 10 to the power of minus 6 Tesla in the positive z direction. Now if you add them together, that's going to give you 4.67 times 10 to the power of minus 6 Tesla in the positive C direction. So that's going to be the magnetic field to the, so in this location, magnetic field in the location due to each of the both current, right? So the resultant current, this resultant magnetic field is going to be this one, and that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.